Hello everybody. So for the lecture 8 week 9 for PN4045, a couple of things we're going to look at in this lecture. And last week we just started a tutorial with Python programming and looked at some of the basics. So I'm just going to kind of run through a few things with you and how that relates to or in terms of applying it to your project work for your environmental project, finding that data, um, gathering that water conservation data, and looking at how you can analyze it and try and filter your way through it to find or design a solution for the second part of the project. So we're going to look at a couple of things, but just to I suppose talk about it in a bit more detail in relation to um, what exactly is going on in terms of the syntax, and looking at simple things like print statements and looking at different types of data types, be that a string where you have text, or be that an integer or a float. So an integer and float are very similar, both numbers, but the float essentially is one with a decimal point, and whereas an integer is a whole number, and the integer might be represented by int. So distinguishing between those different data types does help when you're doing computations like adding things up and stuff like that, and trying to run through a formula or a set of if statements or something like that. So they're just a couple of things to kind of remember there. So we will just open up our Mu editor here, right? So again, simple statement I have here. This is the what you downloaded last week. So I've said here print hello world, right? And very simple, it prints it off in the display down below. So anything that that I want to do in terms of text obviously needs to be contained between two string or two quotations. Um, the beauty of something like this, like the Mu editor as well, when you actually start to decide to write something, um, it will actually give you kind of hints, or tell you. So if I'm going to print something, you can see there it brings up, it says look, object, separate, end, and gives you different hints in terms of what to do with it. So if it is a statement, then I can just print that up there and put that between the quotation marks and it'll print my statement. Whereas if I look at a number or an integer, I'll just print 2. And whereas if I look at a float, I'll just go to 3.45. So you can see there it'll print my respective numbers and text or whatever. So the beauty of that then is, if I start to play around with this and actually look at, okay, so let's say I go print 2 plus 3, and I go stop and I run it again, that automatically computes that it's a number. But what if, for example, I wanted to, let's say for pig iron, I put in this into quotation marks and I add 3, let's say, for example. What happens there? So it tells me the errors, and this is something to get used to in terms of type error. Must be a string, not integer. So it's telling me if I'm adding two pieces or two data types, string. So if both of them are an integer, the computer will add them up. But if both of them are not integers, then it's not going to add them up, and it's telling it needs to be a string. So let's say, for example, I put quotation marks around the 3. If I stop and run, and you can see it, what it does is it actually puts them side by side and creates the number 23. So it interprets, it treats them like a piece of text, and it's effectively changing its data type. So that's a useful thing to know then. So if, for example, I wanted to add a piece of text to something, for example, here in terms of my my name, for example, what's it going to do? It's going to add them together. Hello, Paddy. And let's say, for example, I don't want it all in one string. I want a bit of a space in there or something like that. So I'm going to add in quotation mark, a space bar, quotation mark, and I'm going to press plus. I'm going to stop and I'm going to run that. So you can see there, hello, Paddy. And you can see then by using or not using those quotation marks, it's changing it from a string to an integer or whatever. So they're important things to realize and to be aware of. Okay. So then in terms of obviously the float is pretty much the same and behaves pretty much in the same way. So print 4.5 and divided by, let's say, 2 for argument's sake. If I stop that and run that again, you can see there it'll give me an answer of 2.25, so it runs that answer for me in the output below. So how the data are how the data type is represented in the print statement is obviously very important then for the actual output. So just that's something to be aware of then in relation to the data types. Okay, so the next thing I want to talk to you about is data input. Okay, and that it can be very useful in Python and can particularly be useful for you if, for example, you want to put together a load of data and compute what the kind of average output is, or what the kind of the potential input is if or potential usage of water, maybe if someone uses a certain amount of objects in the home for a certain period of time and so on. So this simple example that we're doing in the labs is a good way of looking at. So important to note as well, what we've done is created these variables, right? And that's called first name and surname. Okay, and these are just assigned names, the same way we'd use a variable in X or Y when we're using algebra and maths. We've just called it first name and surname. And then the formula here is just asking us input, which is a command in Python, asking you for an input. And what it says, what it's going to print basically is enter your first name, and it's asking you to put in your first name and enter that input. Then surname, and then print. So when I actually run that, and you note there in the print, like we talked in the last section about in the print statement, you're effectively kind of adding bits of strings together to make a full sentence. So it's hello plus space plus first name plus space plus surname. So we're going to run that there. So it's running it, enter first name. So it asked me for an input, which is obviously my first name, asked me for my surname, and it says print is not defined. And why is that? Well, because we have P, capital P on the print, and we have a print statement there. So simple mistake, and again goes back to the importance of syntax as well, like I was talking to you about during the week. So Paddy is my first name, obviously, and then Rowsome, and it says hello, Paddy Rowsome. So if for example I wanted to add bits like that, or add let's say an inverted comma after the hello or whatever, I can also add in things there where I deem fit. So it says hello, Paddy Rowsome, and I could add in a full stop or whatever as well to put a bit of structure on the sentence if I needs be. So you can see there that's asking for inputs in those particular instances, and again those variable names are randomly assigned, so you could create your own name for each variable, and in this case first name is Paddy obviously and surname is Rowsome, and we're just adding those strings together. Now, another example of where it asks for data input, and also important to remember in terms of the data types that we discussed in the previous one, and that is looking at floats, and in this case we're asked to give the base and the height and the air, and it calculates the area. So again, these are variables that we've assigned. So base, and we also have height, and that they're calculated. So the area gives us the base multiplied by the height. So again, it's asking us for inputs here, but there's an important thing we want to distinguish and think about the data type in terms of, on the previous example, we looked at whole numbers and adding whole numbers together. And then we looked at looking at data types in terms of floats, which are numbers with decimal points. We need to tell the computer effectively that this is, we're entering numbers that potentially could be floats or could be, have a decimal place. So I'm just going to stop that for a second. I'm going to make sure I save this, and I'm just going to call it area formula. Click save, and again I'm going to run my program. So base is just a randomly assigned variable that I created. Height is the same, and then we just take those two variables down here and multiply one by the other. So it asked me for the length of the base, so I could say 4.5 if I wanted to. Measurement of the height, I'll say 3.5, and the area is given to me then as 15.75. But allowing that to recognize the float is very useful in that instance, because otherwise it might not compute or allow decimal places to be shown in the answer of the formula. So they're important to remember as well. Again, syntax is important, making sure I have my capital or my lowercase p for print statements and so on. And then literally what I'm doing in the print statement is I'm writing in the string area is ... and then a space, and I have that contained quotation marks. And then I wanted to print the variable area, which is base by height up here, which I've distinguished up here, base multiplied by height, and that gives me that area. So you can see the importance of your variables along here. When they're defined and declared at the start, then you can pull and use these different variables as you go down through the formula. And it's quite easy to see in these simple little problems that we're doing, basic kind of maths problems. But as the programs get more complex and as you add more variables, then it's really useful to make sure that you know how you've defined your variables and what kind of names you've given them, because you're going to call on them on a couple of occasions. Okay. So for the next part, we just want to look at if statements, and also referred to as if-else statements. And what they are effectively is if a condition is met or if something is true, it will follow that procedure. If not, something else will happen. Hence the if-else statement. So just starting off with a very simple example here. If 8 is greater than 7, I'm asking it to print the word true. So if 8 is greater than 7, print true. And of course that is the case. So if I change that around, if I said if 3 is greater than 7, print true, click run, and you can see there nothing happens below. It doesn't print. So that gives me options in terms of if you go back to, let's say, the decision blocks in Circuit Wizard, it allows me to decide and in any kind of flowchart kind of format, when you meet a decision block, you can go one way or the other. It can be yes or no, or true and false. So that's essentially kind of something similar that's happening here, just in relation to writing if statements as well. So if, for example, let's say if let's say 25 is greater than, let's say 13, and I write that like I'd write any kind of maths equation when I'm going greater than or less than. And important there is the 2 dots, okay? And what that indicates is there's something to follow, essentially. There's going to be something after this if statement. And when I press enter, you'll actually notice that it automatically indents. So integrated development environments like Mu or Tunny or different ones, even ones that you'd use with the microbit and stuff like that, they are quite intuitive and they know that the next statement needs to be indented. So and that can be done by the tab key as well, but generally a lot of these editors will do it, or these environments will do it automatically. So I'm just going to tell it to print a string, and in that string I'm just going to call say true. Okay, so when I run that, I'm going to have to save it first, so I'll just say ifs. And when it runs there, you can see the answer is true. Okay. Now, a few things, and always going back to our syntax as well in relation to this. If, for example, you print it or you run it, but I say, for example, I deleted the tab or the indent that was there on line 3, and I press run there, you can see it's telling me there's something wrong here. And like I said, it's quite intuitive in terms of it's saying indentation error, expected an indented block. So the mu will tell us, oh, you should have actually indented that there and moved that out to its corresponding position. Also as well, for example, it can be quite fussy if I took out the two colons there, or the two dots. You can see syntax error, invalid syntax, so it might give me some problem there. So you're looking for something, did I leave something out, did I leave a set of inverted commas or two dots or anything like that, did I leave a curly bracket out, something like that. Always look and check to see if those things are there or not there. So they're important to remember and be aware of. As well, so if, for example, okay, 25 is greater than 13. Let's say that's not true, or I change the statement. Then we can use something what's known as an else statement. Okay, so let's say else, and I'm going to say print, lose the capital P, the word false, and close my brackets. So I'll run this now again. So it is the case where 25 is greater than 13. But if I was testing a whole load of variables, and let's say 11, so if 11 is greater than 13, obviously we know that's not true. So it'll check to see if that's true. If it is true, it'll print this statement. Else, if not, essentially it will print the false statement. And that can go on and so on. So and I can add in different ones there. But just before I do that as well, let's say I was testing a whole load of variables and I wanted different values, so I'm going to, or a whole load of different numbers. So I'm going to say, I'm going to call A11, and I'm going to input a variable, call it B is equal to 13, and I'm going to add those into my program there. So to test then, I'm actually going to say if A is greater than B. And remember that the variables have to be declared at the start of the program. So we identify our variables and give them a value. So in this case, I'm just using A and B. I'm asking the question, if A is greater than B, print false. Or print true, if not, then print false. So in this case, A is 11, B is 13, it's going to print false. Also as well, if, for example, let's say there might be another condition. So I'm going to use the term elif, okay? So that's kind of else if, and it's another possibility. And I'm going to get it to print another condition here, which is A is equal to B, because that is also a possibility there in this particular equation. So also I have to tell it to test that. So I have to tell it to test. So if A is equal to B, print, I'm also missing a bracket there, I want it to print that statement. And if it is greater, then I'll print true, and if it's not, then I won't. So in this case, I'm going to run that again and actually have my error. I actually need a double there. So that's compare A with B. So I need a double equal to sign there, so two equal to sign. So I'm comparing A against B if it's the same value. In this case it's false. So let's say, for example, I change the variable A to 13. So now variable A and variable B are 13. So ideally then this should say A is equal to B, because what it has actually done there is, in the if statements, I've given it another condition, right? Another else if, and I've asked it if A is equal to B. So it essentially can be three things. A can be greater than B, A can be less than B, and A can also be equal to B. And that would obviously depend on our variables and the variable we give them. That's an example of how we can use those if statements to compare one against the other and use them to print out our various statements, or to do different computations. So if I go back to A and I change A and B and I change that to 11, then in this case it should print A is or it's true. So if A is greater than B, it prints true. So you can see there, and I can run and test through my different outcomes in my if and else statements. So there are a few important things to remember in relation to the if statements. Again, syntax is always important in terms of making sure you have your colons, your print statements correctly, your inverted commas, or quotation marks, your curly brackets, those kind of things, making sure all of those are done out correctly. So for the last portion, I just want to talk to you about project work for the module in relation to the portfolio you have to do for the water conservation project. So that should be done in a PowerPoint format, but again, you're going to be doing sketches and kind of different conceptual designs and stuff that you will import. And what I want you to do is submit all the files in relation to drawing files that you might have, part files in folders, and also things like Circuit Wizard files for programming, and also py files, .py files, Python files for the code that you use for the different examples and stuff. But you can present it in the PowerPoint format. So again, you have to examine the nature of consumption, the nature of water consumption in the household, use primary and secondary sources of data, quantify and present the level of consumption details of each individual in your household, process and analyze gather information using programming coding skills you've learned in earlier tutorials, using the components of computational thinking to aid your thinking and solution. So that should be 3 to 4 kind of outputs there. And that particular PowerPoint there is set up in an A3 format, so you can use that size of PowerPoint slides. So you're trying to break down the data and show a bit of interrogation of the data and what it actually tells you about the problem. And the purpose of this exploration is to understand the problem a bit more. Then the next stage is kind of ideate, prototype, and test. And this is in the format of 3 kind of outputs, which are going to create a technological solution, use a microcontroller that will help you with this solution, and outline appropriate materials and stuff like that in terms of its design and output, present appropriate circuits, diagrams, schematics, working drawings for the design. So that's going to be in the format of 3 outputs as well. So you'll present this in week 13, and we will, but I want to see it in this format, and we'll go through it then when you present it as well. So make sure that you're touching kind of all those points that are outlined there, and that you're not leaving any detail out in terms of the design. So the schematic or the flow chart that you draw, the circuit diagrams or the PCB layouts that you use in terms of motors, any sensors that you integrate into the project, things like that. Make sure that all that stuff is detailed appropriately for your design. Okay.